Cosmic phenomena that question our current understanding of space have always fascinated scientists, philosophers, and dreamers alike. Among the many marvels unveiled by modern technology, one of its recent highlights includes a revisit to the famous Pillars of Creation, an awe-inspiring formation located within the Eagle Nebula. Originally captured by the Hubble Space Telescope in 1995, these immense columns of gas and dust have become symbolic of star formation itself. However, they have never been viewed with such clarity until now, thanks to the James Webb Space Telescope's advanced infrared sensors. Through Webb's unparalleled capabilities, it has revealed infant stars developing inside the very pillars once shrouded in mystery, some nearly a few 100,000 years old. This breathtaking discovery not only captivates the eye with its ethereal beauty but also deepens our insights into stellar formation and the dynamic forces shaping such celestial wonders, reinforcing our sense of awe and expanding the frontiers of astrophysical knowledge. Following its monumental achievements with the Pillars of Creation, the James Webb Telescope directed its focus toward the enigmatic Pandora cluster, an area named after the mythic figure known for her boundless curiosity. Much like the metaphorical opening of Pandora's box, Webb's observations of this cluster unearthed astonishing surprises that defy conventional expectations. Utilizing Einstein's theory of general relativity as a guiding principle, Webb produced a sweeping panoramic image of Abell 2744, displaying approximately 50,000 infrared light sources. These included galaxies previously concealed from our view, now brought into clarity for the first time. These newly revealed galaxies owe their visibility to Webb's unmatched imaging capabilities. With its advanced observational methods, Webb enabled astronomers to peer deeper into the structure and makeup of this cosmic cluster, offering rich data that could fundamentally reshape our comprehension of galactic evolution over cosmic timescales. Yet Webb's exploration didn't pause with these accomplishments. It continued its interstellar journey, setting its sights on a distant and peculiar stellar body known as WR-140. This object is encircled by concentric, wave-like rings that captivated and puzzled scientists. What made these rings even more baffling was their slightly squared form, as if frozen in motion, an effect initially thought to be merely an optical illusion caused by light diffraction. However, further scrutiny and rigorous analysis revealed a far more intriguing and unexpected phenomenon. The star itself appears to emit pulses of material that ripple outward, forming the distinctive ring patterns captured with stunning detail by Webb sensors. This extraordinary find not only demonstrates Webb's astonishing accuracy but also opens up new questions about stellar life cycles and the invisible forces sculpting their immediate environments, allowing scientists to approach age-old astronomical puzzles with new tools and perspectives. Perhaps the most astonishing discovery made by Webb came when it detected dim red galaxies situated at the very boundary of the observable universe. These colossal galaxies, estimated to be 50 times more massive than any previously identified structures from such an early epoch, emerged when the universe was a mere 3% of its present age. Their very presence challenges existing theories of cosmology. How did such massive structures form so soon after the Big Bang, when matter should have still been assembling into simpler systems? Scientists now aim to revisit these ancient galaxies using Webb's sophisticated spectroscopic capabilities to analyze their light signatures and reveal their underlying physical and chemical properties. The implications of these investigations could significantly reshape our understanding of the universe's formative years, challenging long-held assumptions and possibly rewriting the early chapters of cosmic history. Thanks to its powerful infrared technology, the James Webb Telescope can pierce through dense cosmic clouds and dust, exposing regions where stars are actively being born. These stellar nurseries, previously hidden from other telescopes, now offer rare and intimate glimpses into the early stages of star development. Among these groundbreaking discoveries is a particularly dense cluster found in the Tarantula Nebula, specifically in a region known as 30 Doradus. Webb unveiled hundreds of young stars and protostars at varying developmental phases, giving scientists what amounts to an almost real-time perspective on how stars originate, evolve, and interact with their turbulent environments. These observations promise to revise our understanding of star birth and the significant role that cosmic dust plays in the ongoing evolution of galaxies, acting not as mere interstellar debris, but as an essential ingredient in the cosmic recipe of life. Webb's cutting-edge instruments aren't limited to faraway galaxies or distant stars. They're also unveiling secrets of planets beyond our own solar system. By analyzing light that filters through the atmospheres of exoplanets, Webb can detect specific chemical markers that reveal their compositions with a level of detail previously unimaginable. One of the most exciting breakthroughs to date is the identification of water vapor in the atmosphere of the exoplanet WASP-96b, a distant gas giant orbiting a sun-like star. This major stride in exoplanetary science brings us tantalizingly closer to pinpointing planets that may harbor life. These results not only provide a proof of concept but also pave the path for deeper investigations into smaller, rocky exoplanets that more closely resemble Earth. These investigations compel us to ask the timeless question: are we alone in the cosmos? The James Webb Telescope has also illuminated one of the universe's most elusive and enigmatic components: dark matter. By observing gravitational lensing, where massive cosmic clusters bend light from background objects, Webb has helped create high-resolution maps of dark matter's otherwise invisible distribution. One of the most critical contributions from Webb's ongoing dark matter research is its improved accuracy in detecting lensing effects. This precision allows scientists to more effectively estimate the mass and dynamics of these hidden components, which are believed to constitute roughly 27% of the entire universe. This remarkable progress brings us closer than ever to demystifying the true nature of dark matter and understanding its profound influence on the structure and behavior of the cosmos. Another major advancement stemming from Webb's research lies in measuring the universe's rate of expansion. By carefully examining redshift, the stretching of light caused by the expanding cosmos of distant galaxies, Webb has achieved unmatched precision in calculating how quickly the universe is growing. However, its findings have added complexity to an already nuanced topic. There appears to be a measurable mismatch between the universe's expansion rate in its early history and the rate observed today. This discrepancy hints at unknown forces or phenomena possibly influencing cosmic acceleration, thus challenging established cosmological models and raising profound questions about the ultimate fate of the universe. Will it continue expanding indefinitely? Or could it one day reverse, collapsing back upon itself in a so-called Big Crunch? One of Webb's central missions is to detect the first luminous entities, galaxies and stars, that came into existence within the universe's first few 100 million years. These ancient structures are vital to understanding how the cosmos was born and how matter began to organize into more complex systems. Webb has already observed some of the most distant and faint galaxies ever seen, their light traveling for more than 13 billion years to reach us. These observations help scientists reconstruct the early phases of the universe, shedding light on how matter clustered into stars and galaxies in the turbulent aftermath of the Big Bang. While Webb excels at exploring the formation of stars, it has also offered remarkable glimpses into their deaths. When massive stars exhaust their nuclear fuel, they end their lives in titanic explosions known as supernovae, dispersing heavy elements such as iron, carbon, and hydrogen throughout space. Webb's capacity to capture these cataclysmic events in exquisite detail has empowered astronomers to study stellar life cycles more deeply than ever before. The telescope has even witnessed the creation of the fundamental elements, the very building blocks of life, within these fiery cosmic deaths. Through these poignant and violent scenes, Webb is revealing how life-essential elements are born, evolve, and are ultimately scattered across the universe, seeding the potential for future solar systems and possibly even life. Beyond stars and galaxies, Webb has also examined quasars, extraordinarily luminous objects powered by supermassive black holes at their centers, which consume immense quantities of surrounding material. By focusing on some of the most remote quasars ever recorded, Webb offers fresh insights into these enigmatic sources of energy. These ancient quasars, formed when the universe was still young, provide key data that help scientists understand how black holes evolve and impact their surrounding galaxies. The telescope's findings are helping researchers piece together how such energetic entities can shape the environments around them and even drive the formation of galaxies themselves, influencing the development of the universe at large. In addition to uncovering densely populated galaxies and active stellar regions, the James Webb Telescope has revealed the emptiest stretches of the cosmos, cosmic voids. These enormous, lightless regions, which span hundreds of millions of light-years, present yet another profound cosmic puzzle. Why are these areas so devoid of matter, and what forces led to their formation? By studying the edges of these voids and the galaxies that border them, Webb is helping researchers assemble a more complete picture of how matter is distributed across space, highlighting the delicate interplay between chaos and order in the architecture of the universe. Through all of these groundbreaking discoveries and technological triumphs, the James Webb Space Telescope has not only redefined our understanding of the cosmos but has also transformed the way we perceive our own place within it. From observing star birth and death to detecting ancient galaxies, studying dark matter, and exploring exoplanets, its findings have unveiled a universe far more intricate, majestic, and mysterious than ever imagined. Each image captured by Webb is more than just a visual snapshot. It is a voyage into the past, a glimpse into the origins of everything we know and are. With each revelation comes new mysteries. What mechanisms drive galaxy formation near the dawn of time? Could the unexplored realms of cosmic voids contain clues to the universe's ultimate destiny? And what does the discovery of far-off, Earth-like planets mean for the long-standing search for life beyond our world? These questions, now more compelling than ever, ensure that the journey of discovery continues, guided by the James Webb Space Telescope and the limitless curiosity of humankind. As Webb continues to operate with incredible precision, its long-term mission is not merely to collect data, but to deepen humanity's existential inquiry. How did we get here, and where are we going? With every beam of ancient light it captures, the telescope provides a glimpse into epochs of time far removed from our own. For astronomers and cosmologists, these observations are not passive. They are an act of scientific time travel, permitting a reconstruction of the universe's most formative chapters. One can almost imagine a time when the first hydrogen atoms cooled from the heat of the Big Bang, merging to form the earliest stars that Webb now detects billions of years later. These moments, once sealed by distance and darkness, are now illuminated by our most advanced instrument, granting humanity an almost divine ability to peer into its cosmic heritage. Even within our solar system, Webb's findings have been astonishing. Its infrared capabilities allow it to study planetary atmospheres, icy moons, and even distant Kuiper belt objects with new clarity. For instance, its observations of Jupiter's Great Red Spot, an enormous, centuries-old storm, have yielded vital data on the planet's atmospheric chemistry and internal heat sources. The telescope has also turned its gaze to Saturn's moons, such as Enceladus, which is known to eject plumes of water vapor into space from a subsurface ocean. Webb-sensitive instruments are now able to detect the composition of those plumes with higher precision, offering tantalizing clues about whether life-sustaining molecules exist in that hidden ocean, and reinforcing Enceladus' status as one of the prime candidates in the search for extraterrestrial life within our own solar system. But perhaps the most philosophical element of Webb's mission lies in its impact on human consciousness. The awe that results from seeing newborn stars or galaxies being born in the ashes of stellar destruction evokes something ancient and emotional. As Webb peels back the layers of space and time, it also peels back layers of understanding within ourselves. The discovery of galaxies that should not yet exist, of planets that might harbor oceans, and of cosmic phenomena that seem to defy natural law, these are not merely scientific puzzles. They are spiritual provocations, daring us to reconsider the limits of possibility, of reason, and of faith. Indeed, some discoveries seem to border on the surreal. When Webb identified an exoplanet whose atmospheric chemistry suggested the potential for photosynthetic-like processes, though not directly analogous to Earth's, some scientists paused in disbelief. The implications of such a discovery, even if not life-confirming, are monumental. If other planets host the conditions for even primitive biological processes, then the statistical likelihood of intelligent life elsewhere skyrockets. This notion, long held as science fiction or theoretical speculation, inches ever closer to becoming science fact. It does not mean alien civilizations are imminent or confirmed, but it does mean the conditions that spawned life on Earth may not be as unique as we once thought. The telescope's vast troves of data have also revived interest in one of the most debated topics in cosmology, the concept of a multiverse. As Webb peers deeper into the observable limits of space, patterns begin to emerge, patterns that either confirm or conflict with inflation theory, string theory, and other advanced models of the universe's shape and origin. If anomalies continue to stack, such as massive galaxies where there shouldn't be, or clusters moving against the flow of cosmic expansion, it could suggest that our universe is but one bubble in a vast, multidimensional foam. While speculative, the possibility invites an entirely new philosophical framework, one in which our universe is not the center, but simply a node in an infinite lattice of realities. In addition to scientific communities, Webb's revelations have gripped artists, poets, theologians, and educators. The telescope's first public images were described not only in scientific terms but with metaphors of birth, violence, beauty, and transcendence. Museums and